Bismillahirrahmanirrahim and Assalamu alaikum. My name is Ayan Rafiq and I am a foundation level student at Rehan School Islamabad Barakpur campus. Today I am going to conduct an AI session with Maya. In this session, I will ask few questions and Maya will provide the answers. So let's start. Hey Maya.
Walaikum assalam, Ayan.
My first question is, what is software?
Let's kick this off. Since we're doing the deep dive version, software is essentially the invisible set of instructions that tells a computer's physical hardware exactly what to do. If you think of a computer like a human body, the hardware, the screen, the chips, the keyboard is the physical shell. But the software is the mind, the thoughts, and the logic that make everything actually.
Okay, my next question is, what is the difference between software and hardware?
This is the classic comparison. The easiest way to remember the difference is that if you can physically touch it, it's the physical machinery. Software, on the other hand, is entirely digital. It's the code, the apps, and the operating system. You can't touch software, but without it, the hardware is just a collection of metal and plastic with no way to function.
Okay, my next question is, what are the main type of software?
All right, let's break it down. Broadly speaking, software falls into two main camps: system software and application software. System software is the foundation. It's the stuff that runs in the background to make sure the hardware is actually working, like your operating system, Windows, Mac, OS, or Linux. It's basically the manager that handles the memory and the processor, so everything stays organized. Then you have application software, which is what we actually use to get things done. These are your apps, Chrome for browsing, Spotify for music, or even a word processor for your law studies. One
Next question is, what is system software?
Let's dive deep into system software. System software is the essential layer that sits right between the physical hardware and the application software you use. Its primary job is to control the internal operations of the computer so that everything runs smoothly without you having to worry about the technical guts of the machine. The most prominent example is the operating system, or OS, whether it's Windows, Mac OS, Linux, Android, or exactly. The OS is the big boss. It manages your computer's memory, handles the CPU's workload, and makes sure that when you click a button, the hardware actually responds. It's the reason you can just open an app without having to manually tell the hard drive where to find the data.
Okay, my next question is, what is application software?
Application software, or just apps is for short, is the software designed for the end user to accomplish specific tasks. Unlike system software, which works in the background to keep the machine alive, application software is what you actually see and interact with on your screen. It's the tool you use to get a job done. For example, if you want to write a legal brief for your studies, you'd use a word processor like Microsoft Word. If you want to research a case, you'd use a web browser like Chrome or Safari. If you're just trying to relax with some music, you'd open Spotify. Basically, it definitely is when the right software is running on it. It's that perfect balance between the physical machine and the code that makes everything feel seamless. Do you have another question for the session?
So my next question is, what is programming?
Let's get into the heart of how software is actually made. Programming. I'll be right here with you whenever you're settled in the room. Just let me know. And
Okay, my next question is, what is coding?
since we're doing the deep dive, let's look at coding. Coding is coding is the actual act of writing the instructions that the computer follows. Programming is the big picture, like architecting a whole building. Then coding is the literal bricklaying. It's the process of using a specific programming language like Python or Java to translate a human idea into a language that a machine can understand. Computer following a sum or launching a rocket. This is where we move from just writing code to the actual process of creation. Developing software is a lot like building a house. You don't just start nailing boards together. You follow a structured process called the Software Development Lifecycle, or SDLC. First, you start with planning and analysis. This is the why and what phase. You figure out what problem the software is solving, who the users are, and what features are absolutely necessary phase. Engineers decide how the software will be structured, how the data will flow, and what the user interface will look like, so it's actually intuitive to use. Then comes the actual implementation, or
Okay, my next question is, what do a software developer do?
wait, I want to make sure I'm following you. Are you asking what tools I personally use to function, or what tools a developer needs to actually build software? Tools developers use, they usually start with an ID. All right, let's get into the developer's toolkit. To build software, a developer needs a few essential tools to make the process efficient. The big one is the IDE, or Integrated Development Environment. Think of this as a superpowered editor. Instead of just typing words, an IDE like Visual Studio Code or IntelliJ highlights errors and allows you to run the program with one click. Then you have compilers and interpreters. Since computers only understand binary zeros and ones, they can't actually read the Python or Java that a human writes. The compiler or interpreter acts as the translator, taking that human readable code and turning it into machine code that the processor can actually execute. Beyond that, there's version control, with Git being the industry standard. It's essentially a giant undo button and a history log. It allows developers to save different versions of their project. So if they make a massive mistake and break everything, they can just roll back to a version that actually worked. It's also how teams work together on the same project without accidentally overwriting each other's work. And finally, there's debugging tools. No one writes perfect code on the first try. There are always bugs. Debuggers let the developer pause the program mid-execution to see exactly what's happening inside the memory at that specific moment, which helps.
Okay, my next question is, what is the difference between a software engineer and a programmer?
People use these terms interchangeably all the time, but there is a distinct difference in the approach. A programmer is someone who can write code. They are the specialists in language itself. They know the syntax. They can take a specific problem and translate it into a functional piece of software. If you need a specific feature built or a script written to automate a task, a programmer is your person. They are focused on the how of the code. A software engineer, however, looks at the much bigger picture. They apply engineering principles to the entire life cycle of the software. they aren't just thinking about the code for today. They're thinking about how the software will scale in 5 years, how it will interact with their systems, and how to make it maintainable for a team of 100 people. They focus on the why and the whole, the architecture, the reliability, and the overall system design. In short, a programmer writes the code, but a software engineer designs the entire system that the code lives in.
Okay, my next question is, what is ChatGPT?
Charity, in its simplest sense, is the act of giving help, money, or food to those who are in need. But if we look at it more deeply, it's really about compassion and a selfless desire to improve the lives of others without expecting anything in return. It can be a formal thing like donating to a large organization, or something small and personal like helping a neighbor with their groceries. It's essentially kindness in action. Does that fit what you were thinking of, or are you looking at it from a more legal or social perspective for your studies?
Okay, my next question is, which programming language is best for beginner?
Back to the tech world. For someone just starting out, Python is almost always the top recommendation. The main reason is its readability. Pythons spend less time fighting with actually learning the logic of how to solve problems. It's like learning to drive, and it just makes the entry point so much smoother. Beyond just being easy to read, Python is incredibly versatile. You can use it for everything from simple building complex AI models, which, as you know, is right up my alley. Other options like JavaScript are great if you're more interested in making websites interactive, but for a beginner, Python's simplicity is hard to beat. Does a particular type of project interest you, or are you just exploring the landscape?
Yeah.
Python with this army knife of because it reads so much like English, it has a low. Did I lose you there? You just went from talking about books in Python to a very enthusiastic, oh. Did something cute just happen in the room, or did you just have a sudden realization?
Okay, my
Intrigue. You've got me curious now. What's happening? Wait, you're leaving already? We were just getting into the good stuff with Python. I'll be here whenever you're ready to jump back in. Bye for now.
okay, my next question is, what is the difference between Python and Java?
And we're back. And we're back. Let's get into this because while both are heavy hitters, they're built for very different things. First, think about the syntax. Python is like writing in a simplified version of Python what might take 10 lines in Java. Java, on the other hand, is much more strict. It's a statically typed language, meaning you have to be very explicit about the type of data you're using. It's a bit more tedious to write, but that strictness is actually a superpower for huge projects. Catches a lot of errors before the code even runs, which is why it's the go-to for massive corporate systems and Android app development. Then there's the performance. Java is generally faster because it's compiled into bytecode that the machine can process more efficiently. Python is interpreted, meaning it's translated on the fly, which makes it slower for heavy computation, but way faster for developer to write and test. Essentially, Python is your agile, fast prototyping tool, while Java is the sturdy, industrial strength engine used for building skyscrapers of software.
What is HTML?
Now we're moving into the visual side of things. Since we're doing the deep dive, it's important to start by clarifying that HTML isn't actually a programming language, it's a markup language. Hypertext Markup Language, or HTML, is the skeletal structure of every single website you've ever visited. Imagine you're building a house. If the software logic we talked about earlier is the electricity and plumbing, HTML is the framing and the walls. Doesn't do anything in terms of logic. It doesn't calculate numbers or handle data. It simply tells the browser what the content is. It says, this part is a heading, this part is a paragraph, this is an image, and this is a link. It uses these things called tags, like H1 for a main title or P for paragraph, to organize the information so the browser knows how to display it to the user. Without HTML, the internet would just be a giant, unorganized wall of text with no structure at all. Of course, a house with just framing is pretty ugly, which is why HTML almost always works with CSS for the paint and decor, and JavaScript for the moving parts. Do you want to dive into how those two work with HTML, or do you have another question on your list?
Okay, my next question is, what is CSS?
If HTML If HTML is the skeletal structure or the framing of the house, CSS is the interior design, the paint, and the decor. CSS stands for Cascading Style Sheets, and its entire purpose is to make the web look good. While HTML tells the browser what the content is, CSS tells the browser how it should look. It handles everything from the colors and fonts to the spacing and layout. For example, if you want your headings to be bold and blue, or if you want your images to be centered with a rounded
Okay, my next question
you
is,
handle the layout and the vibe of the site.
what is JavaScript?
I'm ready. Now we're getting to the real magic. If HTML is the walls and CSS is the paint, JavaScript is the electricity, the plumbing, and the automatic doors. It's the part of the web that actually does things. JavaScript is a full-blown programming language that allows you to create dynamic, interactive content. Without it, every website would be a static page that just sits there. When you click a like button and the heart turns red instantly, or when a search bar gives you suggestions as you type, or when a pop-up window appears, that's all JavaScript at work. It allows to refresh the entire screen, the user session, and even animate elements to make the experience feel smooth and alive. It's essentially what turns a digital document into an actual application. So when you combine the three, HTML for structure, CSS for style, and JavaScript for behavior, you have the complete toolkit for building the modern web. Does that make sense, or do you want to know how they all talk to each other? Let's look at the teamwork behind the scenes. It's basically a three-step conversation. First, HTML tells the browser, here is a button. Then CSS jumps in and says, make script, adds the logic and says, when the user clicks this blue button, send a message. They all work in a loop, constantly updating the page to make it feel like a living thing rather than just a flat file. Does that paint a clear picture, or should we dive into another topic?
Okay, my next question is, what is the difference between a website and software?
This is a great question because the line between them has gotten really blurred. Website was basically a digital brochure. You went there to read information, like a news article or a blog. It was static, meaning it didn't really do much other than display a text computer to perform a complex task like Photoshop for editing photos or Excel for spreadsheets. But today we have something called web applications. Think about Gmail or Google Docs. Technically, you access them through a browser, so they
Okay, my next question is what is desktop software?
Desktop software is the kind of program that's installed directly onto your computer's hard drive rather than living on a server you access through a browser. Because it's installed locally, it has a direct line to your computer's hardware, your processor, your RAM, and your graphics card without needing an internet connection to function. This is why things like professional video editors, high-end games, or heavy software like AutoCAD are usually desktop apps. They need every bit of power your machine can offer to run smoothly. Unlike a web app, which has to load over the internet, desktop software is generally faster and more stable for intense tasks. It's like the difference between renting a tool from a store, the web, and having your own full workshop right in your garage, the desktop. You have total control and it's always there, ready to go, even if your Wi-Fi cuts out. Does that distinction make sense, or do you want to know how it compares to mobile apps?
Okay, my next question is what is an API?
All right, let's get into the secret language of the internet. API stands for Application Programming Interface, but that's a bit of a mouthful. Think of an API as a messenger or a waiter at a restaurant. Imagine you're at a table. Exactly, you're at the table with a menu, the system or the server that has all the ingredients and the power to make the food, but you can't just walk back there and start cooking yourself. That would be chaos. So you tell the waiter, the API, what you want. The waiter takes your request to the kitchen, tells the chefs exactly what to prepare, and then brings the food back to your table. You don't need to know how the oven works or how the chef chops the vegetables. You just need to know how to ask the waiter for what you want. In the tech world, this happens constantly. When you use a travel site to compare flights, that site is using APIs to talk to Delta, Emirates, and United. It asks their systems, what flights do you have for these dates? And the airline's APIs send back the prices and times. The travel site doesn't have access to the airline's private databases. It just uses exactly. The travel site is just the middleman. It uses the API to get the info it needs without having to build its own flight database from scratch. It's basically the universal translator that lets different pieces of software talk to each other. Since you're moving to the next slide, what's the next topic on the list?
Okay, my next question is what is a software bug?
I think you might mean a software bug or maybe software talk in terms of a technical discussion. If you're following a slide deck, it's probably talking about bugs, those annoying little mistakes in the code that make a program crash or act weird. But let me know if it's actually something else.
Okay, my next question is what is uh, what is software testing important?
This is a huge one because releasing software without testing is basically just crossing your fingers and hoping for the best. Imagine if a bank released an app update and suddenly, instead of adding money to your account, it accidentally deleted it, or a hospital software crashed during a surgery. That's why testing is non negotiable. Software testing is the process of systematically checking the code for bugs and vulnerabilities before it ever reaches the user. Actually, I have to stop you right there because our session is about to hit the time limit. We're almost at 30 minutes, so we'll have to wrap this up now. You can always call me back whenever you're ready to dive back in. Bye for now.